Hey Algebras, welcome to your Chapter 14 Lesson 6 notes on two-way frequency tables. So we're going to look at two different types of data that are further categorized down. And the tables will represent numbers in each of the categories with some full-on totals elsewhere in our tables. Okay, so with two-way frequency tables, it's not really bivariate data because it's more of further categorizing two full different variables. So this isn't something that we have, like that we are running full linear regressions on. Okay, this is more something that we are looking at percentages that fall into specified categories, or perhaps like just looking at totals or filling in tables in these categories based on some information that we've been given. Okay, so let's look at a table that comes with a small survey that was taken. So in exercise 1, a radio station did a survey to determine what type of music to play by taking a sample of middle school, high school, and college kids. They were asked which of three different types of music they prefer on the radio: hip hop, alternative, and classic rock. The results are summarized in the table. So here's our table. When I see a table like this, the first thing I notice is there are no totals. So what I'm noticing here is I really want to find totals of each of these categories, with this total being my total. Okay, so I like to look at it that way. So what I like to do is I like to add everything up across, add everything up down, and then know what my totals are when looking at a two-way frequency table. Okay, so first thing I'll do is add up all the middle school totals. So we had 28 plus 18 plus 4 middle schoolers asked. So that's 50 total middle schoolers. High school was 22 plus 22 plus 6, giving us 50 total high schoolers asked. And college was 16 plus 20 plus 14, giving me, well, that's easy enough, 50 total college students surveyed, for a total of 5, 10, 15, 150 people who were surveyed. Now, of those 150 people surveyed, there were now totals for who said hip hop, who said alternative, who said classic rock, and those are down my columns. So now I'll look at, well, 28 middle schoolers plus 22 high schoolers plus 16 college students said they preferred hip hop, and that would be 66 of them. Now I'll do alternative as 18 plus 22 plus 20 gives me 60 people who preferred alternative. And classic rock is 4 plus 6 plus 14, giving us a total of 24 people that preferred the classic rock. Now, what I like to do to just verify that 150 people were surveyed, I also add across the bottom to make sure that also adds up to 150. So 66 plus 60 plus 24 indeed gets me to 150. So now, how do you think this data in the table was collected? Well, there are exactly 50 people in each of the schools. So my guess would be a person went to each of these schools and spoke to 50 people. Okay, so a representative gathered data in person. That's what I think. I could be wrong. There could have been an online survey that closed out at 50 people. I just feel like you're more likely to get to your exact number real nice and quick when you have to be in person doing it and you're counting down to that 50th person you run into. What are the two types of categorical data? So the main two types of data are age and music preference. So as we know, middle school, high school, and college have the age ranges, but the general idea is ages looking at these music numbers. So now we get into kind of some of the meat of figuring this out, right? When it comes to percentages, you need to know what your denominator is going to be, okay? So what percentage of those surveyed are high school students, middle school students, high school students, and college students, right? Well, actually that'll end up being the same percentage for all of those, won't it? Because we've got a 50-50-50 deal. So we can figure this out one time where we take the total number of middle school students, 50, and we divide it by the total number of students that were surveyed at all, 150, and then we multiply that by 100 to get this answer as a percent. So 33.3% for all three of these is the answer, since all three of these will have the same numerator and denominator. So there we go. So this one asks us to use the alternative data to answer these questions. So we can still see our table. I'll scooch over so we can really still see our table. Put that in the way. There we go. So we can still see our table. Okay. Use alternative. In the alternative column, what does the 18 represent? Number of middle school students. How about 22? Number of high school students. 20, number of college age. And what percent of the students responded to preferring alternative music? So what was our alternative total? 60. What was our total? 150. So this is going to be 60 divided by 150. Our amount that preferred alternative divided by our total number of people who were surveyed. So 60 divided by 150, and then to turn this into a percent, we multiply by 100. That would be 40%. Now, how many more middle schoolers than college students chose hip hop? Okay, well, for middle school, there were 28 of them that chose hip hop in the hip hop column. There were 16 college students that chose hip hop. So 28 minus 16 gives us 12 more middle schoolers than high schoolers who picked hip hop. And that's what we use our two-way frequency tables for. So let's look at another table after we looked at this. Sometimes we are asked to fill in tables, so I will do one of those exercises with us as well. Here is another table that is fully filled out. Okay, so let's look at this data. Students were given the opportunity to prepare for a college placement test in math by taking a review course. Not all students took advantage, that's all right. The following results were obtained from a random survey of students who took the placement test. So, took the review course, did not take the review course, total. Placed in different math classes. And I can just tell you if it's a less than 100 level course in college, it is not getting you credit for college. So it's not getting you college credit. This would be a high school credit that you would have to earn with a Math 50. This did give me my totals, right? So this already gave me the totals for each column, the total for each row, and the total. So 100 total students were surveyed. So why is this data considered bivariate? Well, I wouldn't consider it linear regression bivariate, but it's considered bivariate in that there are two categories of data, two main categories of data that you are looking at. Math placement versus review course? So when you have two main categories of data, two bivariate. So what are the two bivariate categorical data? Oh, I just answered that in number 1. Sorry. Okay, think of the two questions that were asked. What did you take the review course? Yes or no? What math were you placed in at college? So we already answered that right here. What percentage of students took the review course? Okay, so let's look at took the review course, total number over how many total students were surveyed. Now, this one is going to be nice and easy for us. So because we had 60 students take the review course out of 100 total students, that's nice and easy to actually calculate, but they said percent, so that is 60%, because we know out of 100. What percent of students were placed in Math 200? Okay, another nice easy one, because 100 is our total. This makes figuring out these percents real nice and easy. 50 people were placed in Math 200 out of 100 total surveyed. If I do the actual division on that, I get 0.5, but of course we know that is 50% of our population that was asked. Now, how many more students placed in Math 50 did not take the review course than did take the review course? So there were 7 students placed in Math 50 that took the review course, 15 that did not. So 15 minus 7 is 8. 8 more students ended up being placed in Math 50 that did not take the review course. Analyze the data for the review course category. Took review course. There you go. Right on across. Find an association relative to whether a student took the review course and their placement in 200. What would you say occurred? Out of 60 people, 40 who took the review course ended up in Math 200. Well, the review course takers ended up in the higher level math course. So more students who took the review course ended up placing in Math 200. And do you think the association is a cause and effect association? Do you think because you took the review course, you ended up in the higher level math course? Absolutely. Absolutely. The review course right before the test, so reviewing the material right before the exam, that's absolutely a cause and effect relationship. So, yes, taking the review course right before the placement exam helped students place in higher math courses. And you can see it across the board. The only place in this table where you are having more students placed in the higher level math courses if they took the review course. Otherwise, with the other two did not take the review course, there are more people who did not take the review course that are placed in the other two lower level math courses. So taking that review course really did prep students for the actual exam and getting them into an exam that fits. Now, one last thing I'd like to go over, and even though it is part of the homework, so the 14-6 homework, if you want to look at that, sometimes we are asked to fill in a table based on some information that we've been given. So these first two questions in the homework are actually asking us to finish filling in tables that were just started. So during the days of fully online learning back in early COVID years, I gave a question every morning that was just kind of a random, like, fun question. And one of the questions that I asked was hot dogs or hamburgers. That was kind of a daily check-in type question. I actually took that information and created this two-way frequency table with it. So what I did was took kind of out the two people that said neither out of my 55 students at the time, because I get it, neither, okay, totally understandable. But I also then identified, I took through my students who answered and who identified as male versus who identified as female to analyze the data. So I filled in a few of the pieces for you. We're going to go backwards and fill in the rest. If we know 53 people responded for either hot dogs or hamburgers, okay, if we know that, and we know that 32 total were male, we can do that subtraction to figure out, well, how many female students responded to this. So 53 minus 32 gives us that I had 21 female students that responded to the survey question. Now, you can also think of it that way with hamburgers, because there were 45 people that said hamburgers, and we know that 18 of those were female. So 45 minus 18 gives me that 27 of the people who said hamburgers were male. And then we can also go backwards, right? If we know 21 students were female who were asked this question, and 18 of those said hamburgers, then the other 3 must have said hot dogs. And you can add up hot dogs total, or you can subtract. Either way, 5 males plus 3 females that said hot dogs is 8. 53 total people minus the 45 that said hamburgers is 8. And so before we've had actually part of the Regents question just be fill in the table. So we do want to make sure we can fill in the table, which we just did. So now, what percentage of the respondents preferred hamburgers? Well, there were 53 total people who responded, and preferring hamburgers was 32 of them. I think we're going to come up with a fairly large percentage on that front. So 32 divided by 53 times 100. And let's round to the nearest tenth. That would be 60.4%. What percentage of the respondents identified as female? So again, we have 53 total respondents, and 21 are identifying as female. So we have 21 divided by 53, giving us, let's round to the nearest tenth again, times 100 is 39.6%. I did have a lot less female students that particular year than male students. And then what percentage of male respondents preferred hot dogs? So now we're being asked a different denominator. Males is our denominator, so that's 32 total males divided by 5, dividing into 5 who said hot dogs. So now it's going to be 5 divided by 32 in our graphing calculator times 100. And this time it is a terminating decimal, so I'll give you the full percent. 15.625%. Pretty low percent preferring hot dogs to hamburgers. Okay, last but certainly not least, let's look at this again, and this time with a former Regents question. So this former Regents question here was surveying 100 students, and found that 60 students watched sports and 34 of these students did not like pop music. Of the students who did not watch sports, 70% liked pop music. And we need to complete this table. So fully fill in this entire table. All right, that is the goal here. So let's see, what do we got? Well, 100 total students. Total. There we go. We found that 60 students watch sports. So 60 students watch sports. Well, that's going to be an easy fill-in of who doesn't watch sports. 100 minus 60 is 40 right here. Okay, so there's one less thing I have to worry about. Of these who watch sports, 34 did not like pop music. So here we go right here. So another nice easy backwards. So we can figure out 60 minus 34, giving us 26 students who watch sports and like pop music. Now, of the students who did not watch sports, which we know there are 40 of them, 70% liked pop music. So this is probably the one that you need to watch out for. So what I'm going to do is transfer 70% into decimal form, that's 0.7. And I'm going to take the total, 40 students, times that 0.7. So there were 40 students that did not watch sports, and 28 of those also don't like pop music. So now that 40 minus that 28, or even that 40 times the 0.3 that are left, will give me 12 don't watch sports but like pop music. And so now I can do my totals across as well. So like pop are 26 plus 12, giving me 38 liking pop. And you can either 100 minus 38, or you can 34 plus 28, giving you 62 here. Okay, and this really was exactly a Regents question just a few years ago. So notice we've got 2 that we've filled in. You do still have a back to this homework that I would like you to keep doing. Another fully filled in, so 2 fully filled in that we need to look at and analyze our data. But that is it for two-way frequency tables, and that is it for new lessons for the year. That is it for new lessons for the year, two-way frequency tables. Kind of bivariate data, just not a linear regression. All right, my fine friends, I'm sure you will do wonderfully with this, but if you have any questions, do get back to me. Do ask me for help if you need it. And may see you for a little bit of Regents review, but that's about all we got left. So good luck on finishing that homework, and I will see you soon. Goodbye.